Okay, today we're going to look at the sampling distributions of sample proportions. What does that mean? Sampling distributions. Distribution is your graph. Sampling are your samples. So we are taking the graph of all the samples of your sample proportions, which are p-hats. So you take a bunch of proportions from samples. You take a whole bunch of samples, you get the proportion of something going on, you put them all into a graph. So that's what we're talking about here, is that graph. Okay, so the mean of that graph will be exactly P, which is your population proportion. So if you want to make a note to refresh yourself, P is the population proportion, and P hat is the sample proportion. So again, the sampling distribution is a whole bunch of P hats put together. So the mean of the sampling distribution, that would be mu, so the mean of all the p hats. So the mu of p hat, the mean of all the p hats, is going to be p, which is the population proportion. Then the standard deviation of all the p hats, the standard deviation of the sampling distribution, we'll use sigma p hat, is going to be P times 1 minus P over N square rooted. Okay, and then we have two rules for using this. The first rule is that you can only use the standard deviation formula if the population is at least 10 times as large as the sample. You need a big enough population to be able to use that formula. And then rule of thumb 2, we saw also in binomial, is that you can say that this sampling distribution of sample proportions, this graph, is approximately normal if n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. Okay, so let's look at where this is on our pink sheet. Here's our pink sheet. Okay, and these first ones are what we used when we did binomial. So in chapter 8, when we did the binomial distribution, we said that the mean was n times p. This was the mean, and this was the standard deviation. And that this whole thing was approximately normal if n times p was greater than or equal to 10 and n times 1 minus p was greater than or equal to 10. That was the only way we could use the normal approximation. Similar, this is going to work the same way for the sampling distribution of sample proportions. So these two formulas here are for our sampling distributions of the sample proportion. Which is p hat. So the mean of p hat, the mean of the sampling distribution of sample proportions, will be equal to p, which is the same as the population mean. The standard deviation of the sampling distribution, the sample proportion, is going to be this formula here. And if you look back at the last slide, we can use that formula only when the population is at least 10 times the sample. So add yourself that little note. So add that we can only use, I don't know why my L won't show up, only, there we go, use if the population is at least 10 times the sample size, which we use n. Okay, so we can only use that formula if the population is at least 10 times the sample size. And then we can say that the sampling distribution of sample proportions is normal, or we can say it's approximately normal only if n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. Just like on binomial. Okay, hang on to these next two things. Those are going to go with sampling distributions of sample means, which we're not there yet. That's for the next day. So I'm going to add in this example here. You do not have this example in your notes. However, you can look off this one. You can write down the main ideas if you'd like. Okay, so according to a market research firm, 52% of all resident numbers in Los Angeles are unlisted. A telephone sales firm uses random digit dialing equipment that dials residential numbers at random, whether they are listed or not in the telephone directory. The firm calls 500 numbers in LA. What are the mean and standard deviation of the proportion of unlisted numbers in the sample? So first, let's define what we have here. We are given the true population proportion of 0.52. So P is equal to 0.52. And then here we're calling 500 numbers, so our N is 500. So we want to know what's the mean and the standard deviation of the proportion of unlisted numbers in the sample. Okay, so talking about the sample, we're going to take the mu of p hat. The mean of p hat is going to be just p. They're going to have the same mean. So the mean of p hat is going to be 0.52. Pretty easy. Okay. Now we have the standard deviation of p hat. The standard deviation of p hat is going to be the formula p times 1 minus p over n square rooted. Now remember, we can only use that formula if the population is at least 10 times the sample size, so we need to check that first. Okay, so something we need to check is we need to decide that the population of Los Angeles is at least 10 times the sample size of 500, which is 5,000 people. Do we believe that the population of LA is at least 10 times the sample size, or at least 5,000 people? Yes, we do. We don't know for sure, but we're going to add in up here that we assume that the population of LA is at least 5,000. Okay, so we can use this formula, which is great. So we have 0.52 times 0.48, which is 1 minus 0.52, over 500, square rooted, and you get 0.0223. Okay, so we got our mean and we got our standard deviation of the proportion of unlisted numbers in the sample. Part B, what is the probability that at least half the numbers dialed are unlisted? So what is the probability that our p hat is less than 0.52? Sorry, 0.50, 50%. What is the probability that one sample is less than 50%? Okay, less than half. So we know that our sampling distribution is approximately normal with a mean of 0.52 and a standard deviation of 0.023 or 0.0023. So that puts this at about 1 standard deviation below. Okay, so we should be able to take a really good guess about what that will be. Okay, this tail will be 16%, so our answer should be about 84%. Okay, so what we're going to do now is use the normal distribution to actually calculate that. But to do that, go back to what we talked about. Our other rule of thumb is we can only say this is approximately normal if n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. So here's how we're going to check that. We are going to say that the sampling distribution is approximately normal because And then we're going to write all this out. N times P greater than or equal to 10. N times 1 minus P greater than or equal to 10. And we're going to fill that in. So 500 times 0.52 is greater than or equal to 10. And 500 times 0.48 is greater than or equal to 10. And I don't know if I can give myself any more room. Let's see. Yes, I can. So 500 times 0.52 is 260. Yes, that's greater than or equal to 10. And 500 times 0.48 is 240. And yes, that is greater than or equal to 10. So we can use the normal approximation. So we're going to normal CDF from 0.50 to infinity, comma mean, comma standard deviation. Sorry for the cramped writing there. And we get 0.815, or about 82%. Okay, and we will talk about this more in class tomorrow. Have a great day.